So while we get that set up, I have the pleasure of introducing our next speaker, Jonas D. Takodjou Wambo, who is a PhD student from the University of Yaoundé in Cameroon. He works under the supervision of Professors Nienti Jean-Paul and Jano Sylvester from the University of Yaoundé, and in collaboration with Professor Paul D. Asimov from the California Institute of Technology, Professor Amin Beiramvan Poor from the University Malaysia Terengganu, and Professor Bazem Zohair from the Benha University of Egypt. Jonas D. completed his bachelor's degree and his master's degree at the University of Yaoundé. And in 2016, he started his PhD on petrogenesis, structurogenesis, and metallogenic potentials of Precambrian formations of Ngoura-Colomines in East Cameroon. Part of his work is focused on the use of remote sensing for mapping hydrothermal alteration associated with gold mineralization. And he is also a senior exploration geologist and geodata scientist working as a consultant for several mining companies, both in Africa and abroad. So Jonas, the floor is yours, and we're looking forward to your talk.
So thanks for the introduction. Hi, everyone. Hope you can hear me well. It's been amazing to follow you on our deposit app. So really great job you are doing there. Congratulations for such a project. I'm really happy to be here today introducing some few insight about the use of remote sensing for gold exploration in subtropical regions. But before we start, I would like to thank my supervisor, that is Professor Zenti and Professor Nganu, both research professors at the University of Yaoundé I in Cameroon. Also a special thanks to our key collaborators, that's Professor Asma from California Institute of Technology in USA, and Professor Pu from Malaysia University, Terengganu, and Professor Zoe from the Benha University in Egypt. So for this presentation, we just start by giving some word about the multispectral data application, but mostly Landsat 8 and ASTAR data, followed by the introduction of remote sensing for gold exploration in subtropical regions in the African continent. And then we just give some word about the geology of the Eastern Cameroon, which is our case study area, and gold mineralization associated hydrothermal alteration in the Ngoura-Colomines area. So we just end by giving some summary and perspectives. So as you may know, remote sensing applications are one of the most powerful new tools in exploration geology, as the effort of exploration geologists are generally hampered by the difficulty, access limit, and both natural and human risk inherent in surveying large area. So satellite remote sensing is an essential low-cost solution for identifying, mapping, and collecting reliable information on prospective or target areas. So advanced remote sensing data has been widely applied for identification and the mapping of surface mineralogy in area of suitable exposure. Now, multispectral images such as Landsat data series, ASTAR data, you have some of advanced land imager and the world view tree that provide reliable and homogeneous information for all mineral exploration around the world. But for this presentation, we just focus ourselves on the Landsat 8 and the ASTAR data because they are more popular due to their spectral capability for geological mapping. So since the launch of Landsat data series at 1970, the technology has improved the increased availability of spectral information in such a way that from ground, each feature we see have its available spectral signature, which can help us to identify and map a range of geological formations and their associated ore deposits. Now, the visible near-infrared, the short-wave infrared, and thermal infrared portion of the spectrum are very important for mapping assemblages of minerals that may be indicative of metallogenic ore deposits, such as hydrothermal ore deposit. You have the porphyric ore deposit, some of the volcanic massive sulfur deposit, iron oxide, copper gold, and so on. So then if you want to find some iron oxide, you need to be focused on the key absorption in the visible near infrared. And for clay and carbonate mineral is all about the short-wave infrared. Now, from those silicate rocks, from acidic to ultra basic and carbonate, and some of those carbonate you can be focused on the thermal infrared regions. Now, orogenic gold and the porphyry copper gold system, just to name a few, are generally associated with hydrothermal alteration zones. Therefore, alteration mapping is one of the most important techniques in the early stage of exploration for mineral resources related to such systems. Here you can see here you have a concept of hydrothermal alterations of porphyritic copper deposit showing some various rock types such as potassic, philitic, argillic, and the porphyritic alterations. In general, the associated zone of hypogean hydrothermal alterations and weathering are spatially large enough to be detected and mapped using multispectral remote sensing data. Now, most of the porphyry copper deposits are characterized by a well-developed zonal patterns of mineralization and wall rock alteration that can be defined by assemblages of hydrothermal alteration minerals. So in general, there is a positive correlation between the size of the deposit and the lateral extent of alteration, but it depends mostly on the type of deposit. It's then very important to be focused on key mineral indicator on the surface, coupled with good information, with good geological information. For this purpose, you could just use hyperspectral data or multispectral data coupled with geophysical and field investigations. Now, several studies have proven the reliability of multispectral remote sensing data processing in the identification of hydrothermal alteration mineral associated with orogenic gold and the copper gold deposit. But as you can see here, part of Pan-African fault belt for being intertropical region remain very difficult and laborious area to conduct geological field mapping and mineral exploration. This is mainly due to the permanent presence of heavy vegetation and thick lateritic cover that considerably hinder the observation of basement rocks. That's why using remote sensing for gold exploration in African continent is mostly concentrated in the arid region where orogenic gold occur in the transportional and transtactional zones. So structural analysis, lithological mapping, and alteration zone detection have been implemented for exploration of gold in the hard rock background in the entire northern part of the African continent, as you can see here. But in contrast, there is only few studies using satellite images for gold exploration in subtropical belt of African continent. So here we are just using both Landsat 8 and the ASTER data coupled with some aeromagnetic data and the geophysical and geostatistical investigations for structural interpretation and for exploration of spatial variability of gold content and identification of high potential zone for both ion formation and gold mineralization in Cameroon and the Central African Republic. As you can see here, there's just few work using remote sensing in the subtropical belt of African continents. Now, Landsat 8 and ASTER multispectral imaging offer wavelength that may be sensitive to alteration mineral in heavy vegetation cover. Although the ASTER has two bands, they denoted band 2 and band 3 specific to green vegetation, but that is mostly, this is mostly chlorophyll absorption. ASTER is partly designed for measuring dry vegetation because it sends only the line band at the 2.3 micrometer, which overlaps many mineral absorption like carbonate, chloride, and amphiboles. Consequently, it may be easier to unmix vegetation, both vegetation and mineral information in ASTER spectral in tropical region where most of the vegetation are green and dry vegetation is rare. Now, although Landsat 8 has a fewer band than ASTER, Landsat 8 offer bands that are ideal for isolating dry vegetation, green vegetation, and biosol component. That's why Landsat 8 has been successfully used for identifying hydrothermal alteration minerals at the regional scales. So integrated use of both Landsat 8 and ASTER spectral data is a good approach that may prove optimal for mapping alteration mineral group in the subtropical settings. Now let's move to our case study. Now, first of all, you have to know that the Precambrian constitute the main part of the geological formation in Cameroon and are mainly made up of two lithological entities, including the North Equatorial Pan-African Fold Belt and the Cratonic Domain, which is characterized by the term complex and the term complex of Paleoproterozoic to Archean in age. Now, okay, so in the Eastern Cameroon, I was saying that in Eastern Cameroon, previous geological investigation have recognized a metamorphic basement intruded by seen to post-tectonic granite and granodiorite hosting gold deposit. So in Eastern Cameroon we found some principal three gold districts. We have our Betare Oya, which is up there, Betare Oya district here. We have our Baturi district, which is here, and we have our Boden district that is in our study area where gold occur principally within the northeast, southwest trending shear zones. These structures are associated with quartz, vein, and disseminated sulfide in the meta-volcano sedimentary sequences. Now, when proceed those multispectral data, it's important to, first of all, apply some pre-processing. You have the radiometric calibration, the atmospheric correction using flash or other methods applied on Landsat 8. But for ASTER, you could just apply the crosstalk corrections. Now, when proceeding those images, for Landsat 8, it is all about the principal component analysis, the independent component analysis, and the specialized band ratio techniques. Now, for ASTER data, you can apply the spectral unmixed algorithm through the minimum node fraction, the pixel purity index, and some of automatic n members predictions for the n-dimensional visualizer. At the end, now, you could just put together the most informative thematic layers of alteration zone to generate the mineral prospectivity map of the area of interest. Now let's move to our case study, where we use both Landsat 8 and satellite images to detect hydrothermal alteration zone associated with gold mineralization in the Ngoura-Colomines goldfield. So here, the table screen shows the statistical factor derived from PCA analysis of Landsat 8 through the visible near infrared, the shortwave infrared, and the thermal infrared, where we can see that our PC2 have a moderate contributions of band 4 and band 5 with opposite signs. Normally, those band 4 and 5 is related to vegetation, and so that our PC2 enhance vegetation as dark tone because of the negative sign in the reflection band 5. Now, our PC5 now here, as you can see, so PC5 shows strong contribution band, strong contribution of band 6, as you can see here, and some of the contribution of band 7 with opposite signs. Also, our PC6 here have engine value, have significant loading of band 2 here, as you can see, and band 4. And the latest, which is our PC7, shows strong contribution here for band 10 and band 11. Now, the image screen shows the pseudo color ramp of the PC2, so our previous PC2 roll image in A, where the tendency of vegetation to follow the drainage pattern can be seen, and also the concentration of vegetation here in the northern part of our study areas. Hydroxyl-bearing clay and sulfur group mineral and carbonate mineral are all highly reflective in Landsat 8 band 6 and strongly absorbing in Landsat 8 band 7. Therefore, our previous PC5 image is likely to be show the surface distribution of clay and the carbonate mineral as a bright pixel due to the positive sign in the reflections band. So here in B, we have the high concentration of clay and carbonate mineral, mainly in our western part and the central part of study area. We have some of the northeastern part of the area here. Iron oxide hydroxide mineral group exhibits strong absorption feature in Landsat 8 band 2 and strong reflection in Landsat 8 band 4. That's why our previous PC6 enhanced iron oxide hydroxide mineral in dark tone because of the negative sign in the reflection band 4. So here, as you can see here, the image C highlight iron oxide hydroxide bearing minerals. So we have our oxide hydroxide mineral mostly concentrated in the western part of the study area, some of the central and the northeastern part of the study area. Now, band 10 and band 11 of Landsat 8, there is a thermal infrared instrument, are capable of measuring spectral emissivity feature of silicate minerals. Those our previous PC7 is here in image G, and you can see show some silicifications. That's area of high emissivity. That means high quartz content. So our silicification is mostly in the western part and some of the central and southern part and some of the southwestern part of the study areas. Now, key spectral band ratio and combination was selected to bring out key mineral as a high digital number bright pixel in sense of the study area. So the image A here, as you can see, is about the iron oxide hydroxide minerals, where we just applied the Landsat 8 band, 4/2, which is designed to bring out iron oxide and hydroxide mineral group as high digital number pixels. So these are mostly concentrated in mining site and some surrounding area here, as you can see here. Now, in contrast, in B, we apply iron oxide, we apply iron mineral index of Pu et al. 2018C. That is Landsat 8 band 6/5 times 4/3 that display bright pixel in most of the study area, excepted the northern part, as you can see here, the northern vegetated area here. So the difference between the two index arise because the iron mineral index is sensitive both to iron 2 and iron 3 charge transfer and crystal field absorption feature near 0.9 to 1.2 micrometers. That's why the regionally prevalent of ferricrete, that's iron crocks, appear bright in the iron mineral index image. But normally our 4/2 band ratio, by contrast, is more specifically sensitive to the iron 3 in the iron oxide hydroxide mineral, which are concentrated in the alteration zone associated with gold mineralizations, as you can see here in our previous image. Now, Landsat 6/7 band ratio chosen for mapping clay and some ferrous mineral and carbonate mineral group produce an image in C here, as you can see, that apparently indicate clay and carbonate mineral group in most of the study area, including the highly vegetated northern part of the study area here. In fact, this band ratio overlaps the 2.2 micrometer lignite cellulose spectral band, and so vegetation cover interfere with the clay and carbonate mineral detections. So overlapping absorption band in the wet spray lateritic soil cover may also be some inconvenience in mapping those different mineral species. And better discrimination of clay and carbonate mineral group from both these sources of subtropical interference could be achieved by increasing the contribution of the absorption of band 7. As you can see here, where we use the band combination 6/7 times 7. That exhibit bright pixels spatially concentrated in and around the mining site, achieving the separation of the alteration minerals from laterite and vegetation cover, as you can see here. Now, to map the unaltered rock background, we use the band ratio 5/6 here. As you can see here, our unaltered rock is far away from all those the previous alteration minerals we mapped. Now, for silicified zone in the study area, we just use our combination band of 10 plus 11 times 11. And as you can see here, we have some zone with high quartz content, and that are spatially associated with non-mining sites. Now here you have we just put together all the alteration minerals we mapped to have our prospectivity maps of the study area. That is really important. As you can see here, we have some of the good prospects here in the Yangamo area. You have also the Datamba area here, which is some of good prospect for future exploration of gold mineralizations. You have also the central part here, that is, and also the northeastern part and the southeastern part of the study area. You can also see that we have most of the folds here, so fracturation, some of those fracturation that really affect those alterations and minerals. Now we then just use our linear spectral unmixing analysis to show some of the applying on the southwestern part and the southeastern part of the study area. That is our best prospect, where we have the contribution of hematite here. That is the most important minerals, and some of kaolinite muscovite here, and jarosa, which is the less mineral in this area. And also here we have the contribution of clay, some of those kaolinite, muscovite, and so on. And we have some hematite here in the southwestern part of the study areas. Now we just select those southwestern area and the southeastern part of our study area as a major prospect for future explorations, for gold exploration itself. Now we went on the field, and then we just found some artisanal gold mining sites. As you can see here in A, we have our hydrothermal altar fault and gold-bearing quartz vein here. We have in C some of iron sulfide, that's molybdenite, chalcopyrite, disseminated in the wall rocks. And in C here, we have our layer of massive sulfide, that is pyrite and chalcopyrite. And in D here, we have our mineralized quartz veins. And here we have some let's say some vogue and some holes in our quartz vein that show the infill textures. And in F here, we have our potassic alterations. Now, when we moved around the area, we found also some of gold and chalcopyrite and telluride, as you can see here, that is disseminated in the granodiorite mostly. So we just come out with the one conclusion, which is in the study area, we have both orogenic gold that is controlled by the quartz vein and so on. And we have also the intrusion-related gold. So now we just selected some samples. So we have 4 samples that color 1 to color 4, as you can see here. Yes, and you can see here, so we have the color 1 to color 4, which is altered samples. And we have the model 1, which is unaltered samples. So we just have a powder to do X-ray analysis. As you can see here, our unaltered sample here display primary mineral as expected. So quartz, albite, and autoclays. And all the altered sample, that is called 1 to color 4, display quartz and characteristic peak of index phase for their alteration type. That's mostly goethite and sericite. So the XRD pattern broadly confirmed the result from remote sensing, field investigation, and the petrographic observations. Now, for the summary, we just come out with the integrated use of both Landsat 8 and ASTA data may prove optimal for mapping alteration mineral group in subtropical settings. And then Landsat 8 band 4/2 is more spatially sensitive to iron 3 in the iron oxide mineral group. And our best result is that to better discriminate clay and carbonate mineral group in the subtropical area, we could just increase the contribution of the absorption in band 7. That helps separating alteration mineralogy from laterite and the vegetation cover. So our satellite-based prospectivity map are reliable for exploration of new gold prospective zone in the Ngoura-Colomines goldfield. Now, since remote sensing already highlight the gold mineralization in the area, it will be nice now to be focused. So for future work, it would be nice to design a genetic model for gold deposit in Eastern Cameroon. And then we could just date both host rock and the shared control on the gold mineralization and make some correlation between the gold deposit from Eastern Cameroon and those from the other Pan-African terrains. So thank you. Since I'm really sorry for being fast with the presentation, it's like there's not too much time, so it was not possible to mix all the data here to explain with those just 20 minutes. So to be in confident with those, well, you could go through the Takodjou et 2020 and the Traoré et 2020, which is some novel work using remote sensing in intertropical regions. So thank you.
Thank you very much, Jonas. Yeah, you can ask your question in the chat, and I don't know, maybe Tom, you have some input to bring for the talk.
Yes, thank you indeed, Jonas. That was a masterclass in remote sensing. Very detailed analysis of what you can do with the Landsat and the ASTA data. Thanks very much for that. I think for me, as a non-remote sensing sort of specialist, one of the most interesting slides you showed was the prospectivity map. Would it be possible for you just to quickly flick that up on the screen again? So what I was intrigued here by is of course, all the areas of the red, which the eye is naturally drawn to, and then the gold occurrences, and the apparently puzzling observation that a lot of the gold occurrences there in the central part of that map seem to be in the rather blue areas. Could you just explain that a little bit more to us? Am I reading this correctly, that the high fuzzy memberships are in fact the more prospective areas? And if that is the case, why do we get apparently low prospectivity where we can see those gold occurrences?
Yes, normally here the southeastern part, as you can see here, is a new discovered prospect. So the gold occurrence and the mining site could not, you could not find any gold occurrence and mining site in literature for this area. So is remote sensing help us to go through to find that zone as prospective areas, as you can see. And then when we went on the field, we just find some mining site in the surrounding area, so up there, and then we go through the area now to just sample and analyze those samples and see that there's a gold there. So it's really new discovered prospect for gold in the area.
Yes, well, one hopes so, but it is a little bit puzzling that your prospectivity didn't actually show higher values where you do have those gold deposits there in the center, and even in that sort of arm going off to the east there.
Yes, here is some old mining site where we already know that there's gold there. So so remote sensing also confirmed that this could be good prospect, and that helped us to also being confident with that one in the southwestern part of the study area.
Right. Okay. Well, if I might just ask one more question. You referred, for example, to the ability to distinguish areas of high silica quartz, and you suggested that was representing silicification. How would we exclude the fact that was simply just a primary rock type with a large amount of quartz in, from the fact that it's actually silicification by alteration?
Yes, you are right. We could have a silicification by alteration, but when we went on we went on the field, and then we find that the quartz vein holds gold mineralization. That's why we just being confident with that one. So in the whole study area here, where you found quartz vein, you could just sample it and you will find gold. So gold is disseminated so gold is controlled by quartz veins, but those different quartz veins.
Right. It sounds very. It sounds like a very interesting area. You can find gold in almost any quartz vein. That sounds very interesting. Thank you. Anyway.
Thanks, Tom.
Thank you.
So we have some questions from the audience. Someone is asking if it's possible to determine the orientation of gold mineralization by remote sensing. I guess the orientation of the veins.
Yes, it's mostly we were mostly focused on the orientation of those different veins, and also in this study area, our gold mineralization is controlled by the shell zone. That is our northeast, southwest trending shell zones that control. So all those different quartz veins is along those these shell zones.
So you said northeast, southwest, right?
Yes, the principally northeast, southwest. So the three main districts that Ella said, the Betare Oya, the Baturi area, and the Bodent area, which are our main three districts in ancient Cameroon, are controlled by a mesoscale share zones that trending northeast to southwest.
Because on your perspective, on this map, you don't really see the northeast, southwest orientation.
Yes, this all about the fluctuations in the study area. Because to be in confidence with that one, it would be nice to add now the orientation of those myelonitics that highlight the share zone in the area, and those regional foliation and so on. You will have, so when go through those different work, as I earlier said, it would not be possible. It was not possible for us to put all the work here. As you can go through these different paper, you will see that we have mapped the share zones. So the mesoscale share zone in the study area that really control the colonization in the area.
We have a question from Gideon. Gideon, I don't know. Yeah.
Okay, that's a great work there, Jonas. And I'm wondering, how deep is the remote sensing going? Because given that in that region, you have very thick weathering profile. And during the weathering, do the hydrothermal, alteration minerals stay the same? Can you see them at the surface, or do they get converted to clays and iron oxide? In which case, how do they get determined?
Okay, that are good questions. Now, in the study area, when using remote sensing, searching for alteration mineral or some, let's say, even those fracturation here is from remote sensing. After doing remote sensing, after that you just go to the field to confirm those deformation at the regional scales. So you can have some of those fractures, some of those foliation plan and so on the field that help you to confirm with the to come out with the good result. So our alteration were both on the surface, and because we have some hole there, we just manage some hole here to see the evolution of alteration in the study area. And then we have our surface clay, and when you go deeper, to be closer to the auriferous quartz vein, you see that there is a pattern in the quartz vein, and then when you go far from the quartz vein, you can see that the alteration is changing to clay. So we have silicification mostly on the quartz vein, and when you go far from there, you have those different mineral alterations. So it was possible for us to appreciate the alteration, so different, let's say, paragenesis of alteration in the study area.
Great, thank you. Thank you, Gideon, for your question. Jonas, for you, we have an anonymous question regarding this prospectivity map as well. And it seems like there's a lot of the gold occurrences with the yellow diamonds. Are these, like, what kind of occurrences are these? Are these from artisanal mining sites or alluvial occurrences?
Yes, that's mostly related to alluvial, because this secondary gold mineralization in the area. As you can see, those yellow is follow drainage patterns. Drainage pattern, as you can see here in the study areas.
Okay, so this
it's most about the alluvial gold in the study area.
Mm-hmm.
Right.
But some of those, as you can see, also some of those yellow appear on top of the hill here. So here is most about secondary mineral. But when you reach when you reach the top of the hill here, you could just be closer for the primary mineral. So we found in the study area both. We go from secondary alluvial mineral to the primary gold in the both quartz vein and granodiorite rocks in the area.
Mm-hmm. Well, to follow up on that, you mentioned that there was gold, disseminated gold in the granodiorites as well as the quartz veins. And so you showed a slide with those examples. You said you took 4 samples, Colo 1 through 4. Are those both from quartz veins and granodiorite?
Yes, all. Here, as you can see here on this slide, our Mado 1 is an unaltered rocks, so it's a granodiorite itself.
Okay.
That's why we find those primary minerals, quartz, albite, and the autoclays in that one, as expected. And for the others, which is Colo 1 to Colo 4, that was in the alteration zones.
Okay, so did you include any quartz veins in those? I guess quartz veins don't really alter, so never mind.
I was just wondering, what's the plan now? So based on your work, are the company going to prospect in this new southwest area?
Yes, as you can see here, if any company is working in Ngoura-Colomines area, it would be nice to be focused on the southwestern part here. So our good prospect seen to be the northern, the southwestern part of our study area here, because we already know about the Colomines area. So Colomines area is obvious. Colomines area is the whole gold mining area. So then our novel conclusion here is to be focused on the southwestern part of the study area as a good prospect for gold exploration.
Okay. Nice.
Mm-hmm. And
Okay.
I have some more follow-up questions, Jonas, if you're willing to answer. This is mostly about your PCA. You were talking about how for the PCA, you could, the different bands, when you were comparing the different bands to each other, is there a specific correlation between the band and the type of cover on the ground? For example, vegetation, can you tell that band 6 is more specific to vegetation, or because you mentioned lignin cellulose wavelength?
Yes. When using Landsat 8 images, there are some bands as band 4 and band 5 that can be specific to the vegetation. And here, as you can see, as I earlier said, here you can just follow the PC2 using bold band, and then they all highlight the ending value at all. That reflecting that the highly variance amount of green vegetation coverage is the most obvious source of variance here in the PC2. So that's why we use that band to map vegetation. And usually when applying remote sensing in subtropical regions, you need, first of all, apart from those radiometric correction, atmospheric correction, and so on, you need to design a specific method to mask vegetation before any investigations, because vegetation is really hinder the observation of basement rocks. So vegetation is our first problem in the tropical regions.
Mm-hmm. All right, so exploring in subtropics. So what kind of differences would you see in the bands if you moved to a non-subtropic? I'm asking specifically for like if you wanted to prospect for kimberlites. I mean, there would be an alteration associated with that. Is there a specific trend in the bands when it becomes non-subtropic?
Now, normally, when being in intertropical region, it's all about the green vegetations. So it's all about the green vegetation, and dry vegetation is rare in the intertropical regions. That's the difference between from the intertropical region and the other regions for vegetations.
Yeah, thank you, Marion. Those are all the questions I have on my side.
Perfect. No, I don't see any more questions. Tom, do you have anything else to add, or is it?
Yes, Jonas, thanks very much. I did understand entirely what you meant now about the yellow diamonds being alluvial occurrences. That made absolute sense with your prospectivity map. And as you say, it's really very exciting to think about that southwest corner, because your high prospectivity also correlates very well with the known mining sites. So that's actually a tremendous vindication of what you've done. Tremendous result. Well done for that.
Okay, thank you
for bringing that up. It was great.
Perfect.
Okay, thank you. Thank you.